Okay, cool. Yeah, so let's get started, right? So I think we'll spend the first 30-35 minutes on merge sort, right? Revising merge sort, like how it was working. And hopefully you have gone through the merge sort, yesterday, like after I've discussed. So you guys must be a little bit more clear on how merge sort is actually working. So for the first 30 to 40 minutes, I will be spending time on merge sort and, the discussion of time complexity, space complexity, and all these things, right? And after that, we will be solving certain questions from lead code, right? 2 to 3 questions I will take from lead code. Okay. Okay. So let's get started, right? Let's get started. 60% is the test passing marks, right? So if you are scoring within that 60%, above 60%, it's not a problem, right? Okay. Subhajit, if you have read the notice, the answer is already there in the notice. Please have a look at the notice. Okay, so let's get started, guys, right? So, okay, I think I'll pause the charts, right? Otherwise, it becomes very difficult for focusing, right? Let's stop the charts. Okay. Okay. So let's get started, right? So for the first 30 minutes, I think we'll just discuss about merge sort, right? And more interestingly, I am focusing on how merge sort is working, right? That is what we were discussing yesterday. And some of the people had doubts in that, right? So I will take the same example that I took yesterday so that you guys can follow and see what is happening in merge sort. And hopefully, if you have revised merge sort yesterday, before coming to today's class, so you will be in a much better position to understand what merge sort is doing. Okay. So let's just draw the array, and this will help us in time and space complexity analysis also. Okay. So the array that we took yesterday was 8296 5374. Okay. So I'll also try to write, the function context or the function calls here, right? And if you have access to the code, just open it alongside you guys so that you can understand what exactly is happening. Okay. So this is an array of size 8. Okay. So the valid indexes are from index 0 till index 7. So what do? I will be calling merge sort from the main method. What will I call? I will call merge sort. I will pass ARR and 0, 7. These two indices I will pass. So I am asking, hey, can you please sort the array from index 0 till index 7 for me? Now what do? When this function starts running, I see that, boss, I am looking to sort an array which is greater than length 1, right? There are more than 1 elements in this array, so it definitely needs some sorting. So what do? First of all, I compute mid. What is the value of L? 0. What is the value of R? 7. So I compute mid. What will be the value of mid? 0 plus 7 by 2. That is 7 by 2, which is 3. So index number 3 is the value of mid. This is the value of mid. So I tell you, boss, can you please merge sort the array from index 0 till index 3? So from index L till index mid. Can you please sort this part of the array? Okay. I break the problem into a smaller sub-problem. Hey bro, can you please sort the array from index number 0 till index number 3? Then we will see how to sort the bigger array. But can you please sort this smaller part of the array from index 0 till index 3? Okay. Now, the moment you ask me to sort this part of the array, this function starts running. And what I will see, again, this array is consisting of more than 1 elements. Okay. So L is less than R. That is, there is more than 1 elements in the array. So L is 0 and R is 3. So what do? I compute mid. What is the value of mid? 3 plus 0 by 2. 3 by 2. What is 3 by 2? It is 1. So mid comes out at index number 1. So what I will say, boss, can you please sort the array from L till mid? I break it up into a smaller problem. Ki, boss, you want to sort this entire array from index 0 to 3, na? Can you please sort the left part of the array from index 0 till index 1 for me? So I call merge sort ARR, 0, 1. Right? I want to sort this part of the array. Now what happens? This starts running. Again, I see that L is less than R. That means I have an array greater than size 1 to actually do a sorting on. So what do? I again try to break it up into a smaller problem. So I compute mid. What is mid? L plus R by 2. 0 plus 1 by 2. That is 1 by 2, which is 0. So mid also comes at index 0. So I will say, hey, can you please sort the left part of the array from index L till index mid, and L is also 0, mid is also 0. So I call it like this. Hey, can you please merge sort the array from index L till index mid, this part of the array. Now, when this function starts running, what do I see? That L and R are both equal. So there is only a single element. So what job I have to do? I simply return. So now I tell you, boss, try to understand that is from index 0 till index 0. This is a sorted part. This is a sorted part of the array. I return, right? I simply return. Next, what do I see? When I return from here, this context gets destroyed now. Now what will happen, guys? Try to understand. Then I say, boss, okay, the left part is sorted. Can you please also sort the right part, right? I had to sort this entire array from index 0 to 1, and I have made sure that the left part is sorted from index 0 till index 0. Now I will say, can you sort the right part of the array for me? From index mid plus 1. What is mid? 0. So from index mid plus 1 till R. I call MS, merge sort on 1, 1 on this part of the array. And I see that again, this is a single element. So I simply return. I say, boss, from index number 1 to index number 1 is now sorted. Now guys, try to understand. I am again at this function. Okay. And I wanted to sort the entire array from index 0 till index 1. And I see that from index 0 till index 0 is sorted. From index 1 till index 1 is sorted. Okay. So try to understand, guys. From index L till index mid is sorted. And from mid plus 1 till R is a sorted sequence. So what I will say, the left part is sorted, the right part is sorted. Now I will simply call my merge function. So when I am here, now I call my merge function. I call my merge function. Okay. I call the merge function. And what do I pass? ARR, L, comma, mid, comma, R. What is L? Index 0. What is mid? Index 0. What is R? Index 1. So when I call merge 0, 0, 1, now from index number 0 till index number 1 of the array will be sorted. When this merge method runs successfully, from index 0 till index 1 of the array will become sorted. So you merge these two elements and you will get a 2 here, you will get a 8 here. So from index number 0 till index number 1 of the array ARR is now a sorted sequence. Okay. Now once I know that from index 0 till 1 is sorted, I simply return from merge sort 0, 1. This also returns. Okay. Ye merging ho gaya, so I simply return from here. Now where do I go? I was in merge sort 0 till 3. And I know that from index 0 till 1 is a sorted sequence. Dekh lo, from index 0 till 1 is a sorted sequence. Now what do I say? Boss, can you sort the right part? Can you sort the right part for me? So can you sort the right part of the array from index mid plus 1, that is from index 2 till index R, which is index number 3. So now I will make a call to merge sort ARR. I'm running out of space here, but here it will be 2, 3. Okay, I'm just continuing here. You will understand, right? Now, what do I do? This is a big problem for me. L is less than R, right? So I will compute mid. What is mid? 2 plus 3 by 2, that is 2 itself. So mid will come out at index number 2. Okay. So I say, can you sort the left part of the array from index L till index mid? So from index 2 till index 2. And this is a simple problem, base case. So I simply return. I say from index number 2 till index number 2 is already sorted. So the left part is sorted. Okay. Then I say, boss, can you sort the right part of the array for me? From index mid plus 1, that is from index 3 till R, which is also index 3. Okay. And this is also a single element. So I will return. So now what I am telling, boss, from index number 2 till index number 2 is sorted. From index number 3 till index number 3 is also sorted. So the left and the right parts are sorted. So now I will call a merge function. I will call a merge function, right? So when the merge function is called, what will happen? From it, see, the left part is sorted, the right part is sorted. So from index 2 till index 3, the entire array will now become sorted. 2 to 3 index also contains a sorted sequence. This is also now sorted. Okay. Now, so merge sort 2, 3 is done. Now I come back to merge sort of 0, 3. Now you see, guys, from index 0 to 1 is sorted. From index 2 to 3 is a sorted sequence. So what will merge sort 0, 3 do next? It will call the merge function. Ki boss, the left part is sorted. See, the left part from index 0 till 1 is sorted. And the right part from mid plus 1 till R is also sorted. So next I will call the merge function. I will call the merge function. So merge sort ARR 0, 3 will next call the merge function. And what it will pass? L, what is mid? Mid is 1 and what is R? 3. Okay. So from index 0 till 1 is sorted. From index 2 till 3 is sorted. And when I call the merge function, what will happen? The merging happens like this. And from index 0 till index 3 of the main array will become sorted. So you will have 2, 6, 8, 9 here. Okay. So see guys, we are sorting small parts of the array and see we are building our answers slowly, right? Now what I will do? Now I come back. He was from index 0 till 3 sorted. So I return from this wala merge sort. Okay. Now I come back to merge sort 0, 7. The left part is sorted from L till mid. From index 0 till index 3 is sorted. So now I will say, boss, can you please sort the right part for me? Can you please sort the right part for me? So what will happen? From index mid plus 1 till R, I will say, can you sort? What is mid plus 1? Index 4. And what is R? 7. So I will say, can you merge sort this part of the array for me? Okay. Then what will happen? This is a bigger problem. So I will compute mid. 7 plus 4 by 2 is 11 by 2, which is 5, right? So this is my mid. So I will say, can you sort the left part of this array from index L till index mid? Okay. From index 4 till index 5. Now what I will say? Again, a bigger problem. Again, I compute mid, which is 9 by 2, which is 4. Okay. So I will say, can you sort the left part from index 4 till index 4? Base case already sorted. Then I will say, can you sort the right part from index 5 till index 5? Base case already sorted. Next, what I will do? Boss, the left part is sorted, the right part is sorted. So now I will perform a merge operation. So when I perform a merge operation, what will happen? From index number 4 till index number 5 of the array will become sorted. Okay, so the left part is now sorted. Now I will say, can you sort the right part? Can you sort the right part? And this entire tree will happen and the right part will also get sorted. Okay, so after, you break it down 7 and 4, again, you will break it down into 1, 7, 1, 4. Okay, base cases return, perform a merging. Okay, so here's 4 and here's 7 will come. It's getting a little bit messed up, but I hope you understand, right? So from index 4 to index 5 is sorted and from index 6 till index 7 is sorted. So now I will perform a merge. And when I perform a merge, what will happen? From index 4 till index 7 of my main array will get sorted. So here you will get 3, 4, 3, 4, 5, 7. Okay. Or am I missing something? No. Yeah, that's fine. Okay. So now the left and the right part is sorted, right? Now I come back to merge sort 0, 7. What do I see? From index 0 to 3 is a sorted sequence. And from index 4 till 7 is a sorted sequence. So this time I will call a merge. Okay. My L is this, my mid is this, and my R is this. And when I call the merge method, what will happen? From index 0 till index 7 of my main, major array entirely will become sorted. So I perform a merging of these two, and you will see that the main array from index 0 till index 7 will now contain a sorted sequence. That's it. So if I draw it in a more neater fashion, just for you guys to follow along well. Just one sec. 8296, 5374, right? So you break it up, big problem. I break it up into a smaller problem. Can you sort the left part? That is 8296. I again break it up into a smaller problem. Can you sort the left part, which is 8 and 2? I again break it up. Can you sort the left part? Only element 8, base case, return. Can you sort the right part? Single element, base case, return. Both the left and the right part are sorted. Perform a merging. When you perform a merging, what will happen? 2 and 8 will come here, right? Then can you please sort the right part also? 9 and 6, brick problem. Can you sort the left part? Base case, return. Can you sort the right part? Base case, return, right? Then can you perform a merging? Yes. So this part also gets sorted. So the left and the right part are sorted. Can you perform a merging once again? So here you will get 2, 6, 8, 9. Okay? The left part is sorted. Now you will call for the right part. Can you sort the right part, which consists of 5, 3, 7, 4. Okay, big problem, break it up. Can you sort the left part? 5, 3, big problem, break it up. Can you sort the left part? Single element, done. Can you sort the right part? Single element, done. Perform a merging. So this part will get sorted. Okay, left part sorted. Can you please go and sort the right part now? 7 and 4. Big problem. Again, I break it up. Can you sort the left part? Single element, return. Can you sort the right part? Single element, return. Now perform a merging. When you perform a merging, this part gets sorted. The left part is sorted, the right part is sorted. Again, you will perform a merging. So what will happen? 3, 4, 5, 7. Now see, the left part and the right part are sorted. Perform a merging and you will see that in the main array, you will get 2, 3, 4, 5, 6, 7, 8, 9. Okay. Is this making sense, guys? Is it making sense what is happening? Yes. Cool. Cool. So now let us try to merge function can't be used directly now. You have to call the merge function so many times. See, it is not just a single call of a merge function, right? You have to call the merge function multiple times. Okay. Cool. So now let's try to understand the time complexity, right? First of all, can you tell me how many levels are there in this recursion tree? मेरे को बताओ, how many levels are there in this recursion tree if there are n elements in the array? Can you tell me how many levels are there? See, first, what is the depth? See, first of all, you had an array of length 8, then it became 4, then it became 2, then it became 1. So at every stage, at every level, your array size is reducing by 2. Okay. So can you tell me how many levels are there? Log n levels. Yes. If you see now, in the first level, you have a size of 8. In the second level, you have 2 subparts of size 4. In the third level, you have 4 subparts of size 2. In the fourth sublevel, you have 8 subparts of size 1. So at every level, you are dividing the parts into, you are dividing the size of the parts by 2. So here you had 8, then you went to 4, then you went to 2, then you went to 1. And we have already analyzed such a sequence, right? So the number of levels, how come n by 2? It's not n by 2, it's log n, right? It's log n. If you consider an array of size, let's say 16, then you will get a level of 8, then 4, then 2, then 1. So if I count the number of levels or the depth of this tree, right, it is log n. So the number of levels are log n. And can you tell me what is the work that is being done at each level? Look at this bottommost level, right? What are you doing? You are performing a merging of n different elements. See, in this total level, what are you doing? You are performing a merging of n different levels, right? You are merging one size arrays, so n different elements you are merging. Look at this level, guys. What are you doing? What is the work that we are doing? We are performing a merging of 2 plus 2, 4, 4 plus 2, 6, 6 plus 2, 8. So again, we are merging n elements. Look at this level. What are we doing? Again, we are performing a merging of n elements. Okay. And what is the time complexity for merging? We had seen that if you are merging n elements, the time complexity of merging will be big O of n. Yes, everyone agrees. See now, what are you doing in the bottommost level? Let's try to focus, right? What are you doing in the bottommost level? If you look carefully, आप क्या कर रहे हो? You are merging. You are performing a merge operation on one size array. So how many elements you are merging in total? In total, I am merging 8 elements here. How many elements are you merging in this? You are merging 4 sub arrays, each of size 2. So am I not merging 8 elements? Yes. In this level, how many elements are you merging? See, you merge these 4 elements and these 4 elements. So again, you are performing a merge on 8 elements. So at every level, if you carefully notice, you are performing a merge of n elements. And a merge of n elements take big O of n time. Okay. So at every level, you are doing big O of n work. And how many levels are there? There are log n levels. Okay. So what is the total work that you are doing? The number of levels into the work that you are doing in every level. So the work that you are doing in each level is n, and the total number of levels are log n. So the time complexity of merge sort will be big O of n log n in the worst case. So this is the first sorting algorithm that works in the worst case time complexity of n log n. So definitely merge sort is better than, insertion sort, insertion sort, selection sort, or bubble sort that we have studied so far. Okay. अच्छा, किसी ने पूछा what happens if the size of the array is odd? Nothing will happen, right? The left part, one of the parts will have a smaller size and the other part will have a bigger size, right? When we were performing merging of 2 different arrays, did I put a condition that both have to be of the same size? No. So it will happen that, let's say you have an odd length array, right? 1, 2, 3, 4, 5. ठीक है, ऐसा मान लेते हैं 1, 2, 3, 4, 5. Okay. So what will happen? 0, 1, 2, 3, 4. So when you break it up, right? So your left part will consist of 3 elements from index 0, 1, and 2. And the right part will consist of 2 elements, index 3 and 4. Okay. Then again, when you break it, right, the sizes will be different, right? But when we were performing a merging of two different arrays, we didn't put a restriction now that their sizes should be the same. So it will work fine for odd length as well as even length arrays. No problem in that. But the basic thing that we have to understand is at every level, you are dividing the size of the array by 2. So in total, in this tree, there are log n levels. And in every level, at the end of the day, you are performing a merge of n different elements. Okay. So every level you are doing big O of n work and there are log n levels. So the total time complexity will be big O of n log n in the worst case. Okay. Now, if I ask you, what is the recurrence relation of merge sort? What is the recurrence relation of merge sort, right? I want to devise a recurrence relation of merge sort. So can I write something like this? Boss, I want to sort an array of size n, right? So the time taken to sort an array of size n is equal to what were we doing in merge sort? We broke it up into two parts of size n by 2, n by 2. And first of all, I sorted both of them. So I will say the time taken to sort an array of size n is 2 times the time taken to sort array of size n by 2. Okay. You have to sort an array of size n by 2 times. So 2 times the time taken to sort the array of size n by 2. But is my job done? No. After you have sorted these two arrays of size n by 2 each, you have to perform a merging of these n total elements. So how much time will merging take? Plus big O of n. Okay. Once you have sorted the left and the right parts of size n by 2, you need to perform a merging of these n by 2 elements. So total n elements you have to merge. So what is the time complexity for merging? Big O of n. So this is the recurrence relation of merge sort. Boss, the time taken to merge sort an array of size n is 2 times the time that you take to merge sort an array of size n by 2. And then after you have sorted these two parts, you will be spending big O of n time to perform a merging. Okay. And in maths, there is a theorem known as master theorem. We won't be studying in the course, right? But there is a theorem known as master theorem, right? And if you apply master theorem and solve this recurrence relation, you will see that the time complexity of merge sort comes out to be n log n. But as developers, it is better if we can understand it via this route to see what is the actual amount of work that is being done. Okay. Let me unmute the chats, right? Is this understandable, guys? Is the recurrence relation making sense? How many of you guys are clear with the recurrence relation? Yes. The time taken, if I want to sort this array of size n, I am telling boss, it is equal to, you sort this array of size n by 2, sort this array of size n by 2. So 2 times the time taken to sort an array of size n by 2. And once you have sorted the left and the right parts, what you have to do? You have to perform a merging. So that merging will take big O of n time. Let me explain again. देखो, मैं तुमको बोल रहा हूँ, boss, you have to sort this array of size n. Okay. And I am telling you, boss, the time taken to sort an array of size n is T of n. So what I'm telling, if you want to get this, time taken to sort this array of size n, I tell you, boss, first of all, sort this array of size n by 2. That is what we are doing. Then sort this array of size n by 2. So how much time will this array take to get sorted? T of n by 2, right? If the time taken to sort an array of size n is given by T of n, then the time taken to sort an array of size n by 2 will be given by T of n by 2. So sort the left part of the array plus sort the right part of the array. So once you have sorted both these arrays, what you will do? You will perform a merging. So how much time will merging take? Big O of n, because there are n elements. So this is the recurrence relation for merge sort. Okay. Okay. Now, once we understand the time complexity, right, I'll ask you a couple of questions, right? Quick couple of questions. What do you think is the space complexity of merge sort? We have already coded merge sort yesterday. We have already coded. What is the space complexity? First, let us understand the stack space or the call stack. What is the depth of the tree, guys? What is the depth of the tree? Do you agree? The depth of the tree gives me an idea of the call stack space. What is the depth of the tree? Log n? Everyone agrees? Everyone agrees the depth of the tree is log n. देखो ना, first of all, ऐसा देखो, you call merge sort on this, then you call merge sort on this, you call merge sort on this, you call merge sort of this, and then you will return. Okay. And then you call this. So how many calls or contexts will be there in the call stack at any given point of time? The maximum number of contexts that will be given, that will be present in the call stack at any given point of time is the depth of this tree. And what is the depth of this tree? What is the depth? It is log n. Yes, it is log n. Okay. Why it is log n? In the first level, you have size n, then n by 2 raised to 1, n by 2 raised to 2, n by 2 raised to 3. So you compute this value of k, right? Kitna levels? You will get it is log n. So I will tell you, boss, the recursion will take an implicit stack space of log n. Okay. Recursion will take an implicit stack space of log n. But apart from it, do you think you are using any new space in the memory? Do you think? Yes, correct. There is a temporary array that you are creating every time, right? Whenever you are performing the merging, you are creating a new array. So what is the size of that array that you create? Big O of n. Okay. So when you call the merge function, what are we doing? We are creating an array of size n. And then when this function is destroyed, this array will also get destroyed. Are you getting the point? What were we doing? Inside our merge function, we had created a new array of size n. And then when the merge function was completed, right, then that array would have been destroyed. Okay. So what is the space complexity because of that new array that we are creating? Big O of n. है ना? N size का array बना रहे हो ना, तो that is big O of n. So if I ask you what is the total space complexity, it is big O of log n plus n. Itna is space complexity, right? Log n comes from the implicit call stack, and this big O of n comes from the merge method, because in merge method, we are creating a temporary array. So if I ask you what is the worst case space complexity, it is big O of n, because n is the more dominating term when you compare it with log n. So the worst case space complexity is big O of n, and the worst case time complexity is big O of n log n. Okay. So see guys, there is a trade-off between time and space. If you had a look at bubble insertion and selection, the time complexity was more, but the space complexity was less. In merge sort, the time complexity has come down to n log n, but the space complexity has become up by big O of n. Okay? Is this making sense? Yes. Okay. Cool. Now I ask you other two questions. Is merge sort adaptive? Pehla question hai mera. Same. Time complexity for odd size will also be the same. Is merge sort adaptive? Do you think your work will be reduced if you have an already sorted array? The answer is no. Right? Because let's say that you take an already sorted array. Okay. Let's say you take already sorted array, right? You will break it up 1, 2, 3. Again, I will break it up. Let's say 1, 2. I'm just asking, right? Again, you will break it up 1. Again, you will break it up 2. And then you have to perform the merging, right? Again, have to perform the merging. Okay. So you will see that even if your array is sorted, there is no change in the algorithm. So merge sort is not adaptive. Okay. Even for a sorted input, it will take big O of n log n time. So merge sort is not adaptive. Now I ask you, is merge sort stable? Is merge sort stable? And the answer to this is present in the merge method. Where is the merge method? One sec. We had written code yesterday, right? For merge sort. 1 second. This is the merge sort code that we had written, right? So the answer is present. No, this is merge sort. Yeah. Okay. Tell me, guys. Look at the merge method and try to comment. Is it adaptive? See, adaptive is basically, even if you give it a sorted input, right? Even if you give merge sort a sorted input, right? Let's say you have an array like this. 1, 2, 3, 4. Let's see. Do you have to do any less work? See, 0, 1, 2, 3. I break it up. Okay. The left part. Can you sort it? I break it up. Left part. Already sorted. Right part. Already sorted. Then you have to perform a merging, right? And merging will take the same time. Hai na? Then this is sorted. Then you go to the right part. Can you sort this array? You break it up 3. You break it up 4. Okay. Then you perform a merging. Okay. So 3, 4 will be getting here. And then you again perform a merging. So 1, 2, 3, 4. Basically, you are just overwriting the same thing when you do a merging. But even if you give it a sorted array, there is no change in the time complexity because you have to do the same operations again. So definitely merge sort is not adaptive. Now I ask you, is merge sort stable? And the answer lies in this line. The current implementation of merge sort that I have written, it is stable. Why? Let me give you an idea. See what I am doing. Whenever I get the same elements, now see what I am doing. Whenever I get the same elements, I am always picking it up from the left part. What is the meaning of this? Let's try to understand, right? Let's try to understand. 1, okay. Let's say you have 9, then you have 8 star, let's say you have 7, and let's say you have 8. Now let's try to understand what happens. Okay. So this is 0, 1, 2, 3, 4, right? This is an odd sized array. Let us try to understand what happens. Okay. So what I will do, first of all, I compute mid, which is index number 2. So what will happen? Can you sort this part of the array 1, 9, 8 star? Okay. Then what will happen? Index 0, 1, 2. Again, compute the mid. 2 by 2 will be 1. So can you sort the left part? 1 and 9. Okay. Then again, I will break it up. Can you sort the left part? Already sorted. Can you sort the right part? Already sorted. Perform a merging, right? So 1 and 9 will be here. Okay. Then I will say, can you sort the right part of 8 star? Already sorted. Return. Then I will say, perform a merging. So once you perform a merging, you will get here 1, 8 star and 9. Okay. Then I will say, can you please sort the right part? Okay. 7 and 8. Okay. Then what will happen, guys? Try to understand. Again, you compute mid. 4 plus 3, 7. 7 by 2 is 3. So I will say, can you sort the left part? Already sorted. Can you sort the right part? Already sorted. Perform a merging. Okay, 7, 8. Now, guys, try to see. See. Now, when I do the merging, what am I doing? First of all, 1 will come here. Then 7 will come. Now, guys, try to understand. When I compare 8 star with 8 in merging, right? See, this 8 star is occurring in the left part, right? That means it is occurring before 8 and I am picking it up from the left part only. Agar main yahan pe ye 8 ko pick karta na, then it would have been unstable. But whenever you have the same elements na, I am giving preference to the left part. So the element which was occurring at the first, that will remain occurring at the first itself. So when I compare this 8 star with 8, I will pick up 8 star from the left part, right? 8 star. Then I will write 8 and then I will write 9. Are you getting what I'm trying to say? Yes. If I remove this equality sign here, then it will become unstable. So if you use the equality sign while merging, it is stable. But if you not use the sign, it is unstable. Okay? Yes, correct. Correct. Okay. Now let's have a quick poll. Let's have a quick poll. No, k equal to 0 won't work, right? K is not always 0. Okay. So let's quickly have a poll, guys. Let's see and understand where are we standing. And this time I am trying to use a Zoom poll. पहली बार try कर रहा हूँ. देखते हैं कैसे होता है. मेरे को idea नहीं है. Launch. How does it work? I am not very sure. Can you cast a vote? Do you get an option there? समझ आ गया क्या? कितने लोगों को समझ में आया है? This will be simpler, right? Okay. See, stability is basically whenever you are comparing the same elements, now I am choosing the element from the left side. So the element which is occurring in the left is occurring before, and I choose that only. So the relative ordering is not disturbed. Okay. And why adaptive? Because even if you give it a sorted input, now there will be no change. Okay. Okay. Cool. So I think 84% folks are clear, right? So that's great, right? That's great. So understood recursion, but not space complexity. See, space complexity is nothing, right? First of all, you see what is the depth of the tree. That will give you an idea of how many, function context will be there in the call stack. That is log n. But apart from that, look at this. In the merge method, you are creating a new array every time, right? So it is big O of n extra space because of this array. Okay. Please share the code. We'll have a look at it later. I did this code on portal, but one test case did not pass. Okay. We can have a look, right? We can have a look. Dekh lenge. But I don't think it's anything is different. Okay. Chalo. Cool, guys. So let's move forward. Now, tell me, what do you want, right? What do you want? N plus log n is the space complexity. ठीक है? ठीक है. Send the poll. Okay. Now, tell me guys, what do you want? Either I can start off with QuickSort, okay? Or I can, cover some questions on sorting. Whatever you want, we can do. I have already pasted the code in the questions doc, right? Okay. So let's take some questions, right? QuickSort I will take tomorrow, if that is fine, right? So let's take some questions, right? Okay. So that will also give you some idea of, the lead code format and lead code pattern. Okay. So let's start with a couple of questions to, bolster our understanding further. Okay. And I'll try to take some basic questions first, right? So, okay, let's start with this question. Okay. So let's read the question. Let's change the language first to Java. Okay. And guys, all of you who are not clear with merge sort, right? Now I will request everyone to do a dry run on yourselves, right? Because I have tried to do the dry run a couple of times, but now I think it's high time that you do the dry run on a piece of pen and paper. Otherwise, you will never understand. मैं जितना ही बता दूं, till you don't understand how the functions are working, you will never able to understand the higher gist of what is happening, right? Okay. So let us have a look at this question, right? Maximum product of two elements in an array. It's a very basic and simple question, right? So given the array of integer nums, you will choose two different indices I and j of that array. Return the maximum value of nums of I minus 1 into nums of j minus 1. तो ये मेरे को क्या बोल रहा है boss? You have to choose two elements from the array and you have to tell me what is the maximum product of nums of I minus 1 into nums of j minus 1. Now see guys, what is the lead code format? A function is given to us. See, public int max product int nums. So it is given, in the parameter, you have the reference of the array. So you have access of the array inside the function. The array is already available to you. You don't have to take any input. And the return type is told to you an integer. So you just have to find the maximum product of this value and you have to return that answer to the caller. Okay, I don't know who is the caller. I am not interested, but the return type is an integer. So I need to return the answer of this. Okay. Now, and if you go down and look at the constraints, it is the length of the array is between 2 and 500. So these are very, very small constraints, right? So you can write any time complexity code that will be fine. And nums of I is between 1 and 1000. That is also not a problem. Okay. See, we will be mostly interested in the size of the array. It is very small size array, right? 500. So you can use any time complexity. Okay. Now, can anybody help me with the logic of this question? What do you think? When, see, and all the numbers are positive, right? Nums of I, all the numbers are positive. 1 to 1000 means all the numbers are positive. Okay. Let's first understand an input-output example, right? So if you look at this 3, 4, 5, 2 is my array. Okay. Now let's say if I choose the elements to be 3 and 4, then 3 minus 1 into 4 minus 1. What is this product? This product is 2 into 3, which is 6. But if I choose 4 and 5 now, then I will get 4 minus 1 into 5 minus 1. That is 3 into 4, which is 12. And you will see that this is the maximum product that you can obtain. You choose any other two different numbers, you won't be obtaining a product greater than 12. So this is the maximum product and you will have to return this answer. Okay. Similarly, take the second example, 1545, right? 1545. So if I choose these two elements, let's say 4 and 5, right? So what is the output? 5 minus 1 into 4 minus 1. That is 4 into 3, which is 12. Okay. But if I choose this 5 and this 5, what will be the output? 5 minus 1 into 5 minus 1, which is 4 into 4, which is 16. And 16 is definitely greater than 12. So this choice is always better for me. And you will see that, 5, if you choose these two numbers, now this will only give us the maximum answer. If you choose any two other different numbers, you won't get the maximum answer possible. Okay. And in example 3, you just have two elements. So you don't even have a choice. You have to consider these two elements. And what will be the answer? 3 minus 1 into 7 minus 1. Okay. So 2 into 6, that is 12. And that is what the output is. So is everyone clear with the question? Is everyone clear with the question? Yes. You basically have to tell me what is the maximum value of this possible, right? You have to pick up two elements from the array such that this value becomes maximum. भाई question बोल रहा है, very simple question. You just have to pick up two elements. You have to choose two elements from the array such that this product becomes maximum. And then you have to return that maximum product as the output. Okay. Now, guys, tell me, when will we maximize? सोच के देखो very logically. When can we maximize this product? If I ask you x minus 1 into y minus 1, I want to maximize this product. Okay, x and y are positive. So will I not say x और y जितना बड़ा हो सकता है उतना बड़ा लो? Can I not say, boss, I want to maximize x minus 1 into y minus 1. Okay, and x and y are all positive numbers which are in the array. So what I am asking you, I am telling you, boss, you take the two maximum values that is possible in the array. So when I take the top two maximum values from the array now, I will make sure that this product becomes maximum. Do you all agree with this logic? The maximum and the second maximum, I am just interested in those. Just obtain those two numbers and then perform this calculation and return that as the answer. Okay. So now, how do I find the top two maximum numbers? Somebody told bubble sort, and I'm pretty happy that how many passes? 2 passes of bubble sort will do my job, right? 2 passes of bubble sort will do my job. But I am seeing that the constraints are very low, right? From 2 to 500, the size of the array is very small. So मैं क्या बोलता हूँ ना, let's sort the entire array. I don't care. Let's sort the entire array. So what do I use? I use arrays dot sort. I use arrays dot sort. Okay. And what do I write here? Numbers. Okay. You already have the array numbers, so you just write arrays dot sort numbers. So the entire array will become sorted. Now, once your array has become sorted, where will you get the top two elements? Can I say at the last index and at the second last index? Yes. So let's assume that the size of the array in 10 is equal to numbers dot length. I first of all see what is the size of the array. Okay. What is the biggest element? Let's call it x. That will be equal to numbers of n minus 1. I get the biggest element. And what is the second biggest element? Int y is equal to numbers of n minus 2. So I get the top two maximum elements. And what do I have to return? What is my answer? Int answer is nothing but what? X minus 1, okay, into y minus 1. That is what is the answer, right? So I will compute this product, got the maximum product, and I will simply return answer. That's it. See, we didn't have to take the input. We didn't have to print to the screen. This is what I say when I talk of function completion problems. You already have the array numbers available to you, and you can do all the operations that you want, and you have to return the integer. So you return the answer to the caller. Okay. So will we use the sorting? See, I would suggest if somebody is not explicitly telling you to use the method that you have studied, or if the time complexity doesn't force you to use a method that you have studied, then simply use an inbuilt sorting array sort. Okay. And the inbuilt arrays.sort basically takes a time complexity of n log n. Okay. It's n log n. Okay. So is everyone clear with this? Let us try to run the code here. What about main function? That is what I am telling Jyotirma. You don't have to worry about the main function taking inputs, printing to the screen. No, you just have to, complete this function. That's it. Now, who will be calling this function? Where is the main method? Forget about all these things. Okay. Forget about all these things. Okay. So I'll run the code and submit it. Forget static, guys. Abhi mat dhyan do jo important nahi hai. Okay. So is it fine? See, it was success. And it ran faster than 73% of the submissions, right? What if we don't have to sort the custom conditions? Yes, you can have custom conditions. Okay, you can have custom conditions. You pond bracket open bracket close and still working. I didn't get the question, Rajat. Line number 3. Line number 3 is nothing, guys. I have told you, right? There is an inbuilt sorting technique, arrays.sort, right? You write arrays.sort and write the name of the array that you want to sort. So it will sort the array in ascending order for you. So once you have the array sorted, you know that the top two elements, the top two heaviest elements will be at the last two indexes. So you take the elements, find the sum, product and return the answer. Okay. Okay. And if you submit it multiple times, now basically you will get different run times. So don't worry about that. Okay. Don't worry about that. See, 60% हो गया. ठीक है? Cool. You don't put bracket open, bracket close. Already discussed. Length is an attribute in case of an array. Okay. And what I want to compute, I want to compute maximum of numbers of I minus 1 into numbers of j minus 1. Please read the question. Okay. How many of you are clear with this? Do with recursion. Why? Let's see how many of you are clear. Okay. ये अभी Zoom का poll आ गया तो I can conduct more number of polls, right? So just give a quick vote on how many are clear with the question. I think it's a pretty basic question, right? And I am expecting most of the folks to be clear here, right? This way, I don't think there is anything not to be clear about, right? It's very simple, right? First of all, I have sorted the array because I know this product will become maximum if I pick the top two heaviest elements. So मैंने sort कर दिया, found the length of the array, and then what have I done? Where are the top two heaviest elements? At the last and the second last index. So get the elements, perform this product that the question asks, store it in answer, and return the answer. Okay? As simple as that. Okay. So these, this type of function completion you can expect in your test, right? SI type ka questions aane wala hai. You don't have to write the main, you don't have to take inputs. Okay. So I see that more than 90% of the folks are clear here. So I'll share the question link later in the code also, so you can go through that. It's pretty simple, right? Okay. So let's move forward, right? Let's take another question. Okay. So this is not necessarily, related to sorting. Okay. But it's more about, seeing how much you understand, right? It's basic loops and all those things, right? What are the other questions? Just 1 second. This is this partition. Okay. Peak hai, maximum product, and what is here? Okay. Yeah, let's take this, right? Let's take this question. Okay. So this is not actually a question on sorting, if you see, right? But it's more about implementation based question. Okay. So what is the question saying? Given the array numbers, okay, given the array numbers, for each numbers of I, so for every element present in numbers, you have to find out how many numbers in the array are smaller than it. That is, for each numbers of I, you have to count the number of valid j's such that j not equal to I and numbers of j is less than numbers of I, and return the answer in an array. So basically what it is telling, okay, this is again for practice of your test only, these type of questions, or maybe, you have to now be familiar and comfortable with writing these kind of logics, right? This is simple. So see, what is the question telling us? First, let us try to understand. And I will encourage all of you to try this question once on your own. So what is happening? You are given an array numbers, okay? And what it is telling, for every element numbers of I, find out how many numbers in the array are smaller than it. So for every element in this array, I want to find out how many numbers are smaller than this element. That is, for each numbers of I have to count how many j's are there such that j not equal to I and the numbers of j is less than numbers of I. And I will return the answer in an array. So let us take an input-output example and try to understand what is the question doing. So the input array is 8, 1, 2, 2, 3. So what I will do? What I have to do? For every numbers of I have to calculate how many elements are smaller than this. Okay. So what is this first element? 8. Okay. So I am at this element, right? And I need to count how many elements are smaller than this 8. So what I will do? I iterate through the entire array. Okay. So this is my I. Okay. So I am standing on this element 8. Numbers of I is 8. And I want to count how many j's are there such that numbers of j is less than numbers of I, and j should not be equal to I for sure. So what do? I see 1 is less than 8. So this is one element. 2 is less than 8, second element. This 2 is also less than 8. So 3 elements I have found. And this 3 is also less than 8. So for this element 8, there are 4 numbers in the array which are lesser than 8. So I will have to write here corresponding to 8. I will create a new array and I will write here 4. I will write here 4. Boss, 4 elements are there which are lesser than 8. Okay. Then let's come to the second element. My I moves here. Now I am standing at this element 1 and I want to see how many elements are lesser than this 1. I have to count how many elements are lesser than this 1. So again, I iterate through this entire array. I see. Is 8 less than 1? No, 8 is not less than 1. Move forward. Okay. Now I come to this 1. Do I compare 1 with itself? No, now. what it is told me was j not equal to I. There is no point of comparing the number with itself. So move forward. Is 2 less than 1? No, it is not. Move forward. Is 2 less than 1? No, move forward. Is 3 less than 1? No, move forward. You have iterated through the entire array and you see that there is no element which is smaller than 1. So what I will write? Boss, for this numbers of I, you have 0 elements which are greater. See, 0 element. So corresponding to this one, I write 0. Okay. So basically, let's say this is my answer array. So answer of I is telling you how many elements are smaller than numbers of I. समझ रहे हो? What is answer of I telling me? Answer of I is telling me how many elements are smaller than numbers of I in the array numbers. Okay. Now I will move forward. I come to this element 2. I want to find how many elements are lesser than 2. So again, I will iterate through the entire array. Is 8 less than this 2? No. Is 1 less than 2? Yes. So I will increase my count. I found one element, right? Then I won't be comparing this 2 with itself. Move forward. This is a different 2, right? So j is here, let's say. So is this 2 less than this 2? No, definitely not. Move forward. Is this 3 less than this 2? No. So for this 2, you have just one element that is lesser than 2. So what I will write corresponding to this 2, I write a number 1 here. Ki boss, see, answer of I. So answer of 2, right? When I am at index number 2 of answer, it will tell me how many elements are smaller than numbers of 2. That is, one element is just smaller than this 2. Okay. Then I move my I forward. I come to this element. Okay. I come to this element. I want to see how many elements are smaller than this 2. So again, I will iterate through the array. Is 8 smaller than 2? No. Is 1 smaller than 2? Yes. So my count becomes 1. Okay. Is this 2 smaller than this 2? No. Then when I come here, I have to skip this position, right? Because j should not be equal to I. You don't want to compare the number with itself. So I come here. Is 3 less than 2? Definitely not. So for this 2 also, you have that only one element is smaller than this 2. So I write 1 here. Okay. In the answer array. Next, I come to this element 3. Now for this 3, I have to count how many elements are lesser. So again, I iterate through the array. Is 8 lesser than 3? No, move forward. Is 1 lesser than 3? Yes. So count will become 1. Is this 2 lesser than 3? Yes. So my count will become 2. Is this 2 lesser than 3? Yes. So my count will become 3. And will you compare this 3 with itself? No. So total 3 elements are there which is lesser than 3. So corresponding to this 3, I will write 3 in the answer array. So my answer array will be 40113, which will show me कि boss, देखो, अब अगर मेरे को जानना है, if I want to see how many elements are smaller than numbers of I, if I want to get the count of how many elements are smaller than numbers of I, so just go to answer of I. You will get how many elements are smaller than numbers of I. That is what answer of I is denoting. So answer of I tells me how many elements are smaller than numbers of I. Okay. So this array we will form and we will return it to the user. Okay. We will return it to the user. Making sense, guys? Yes. How many of you are clear with the question? How many of you are clear with the question? Okay. Okay. Cool. So basically one thing, right? One thing. So one thing that I will tell you. Okay. Let's try. Can you help me with the, approach? Can you help me with the approach? You will need 2 loops. Okay. Nested loops or what? Yeah, static has gone. Don't worry about static. जैसा दिया है मेरे को फर्क नहीं पड़ता है, right? If static is written, then it's fine. Not written, it's fine. 2 nested loops. Okay. Just think of the basic brute force, right? So the solution is in O of n square. Can we do it in n? Yes, you can also do it in big O of n. But for that, you have to understand hash maps, which we have not done. Okay. So let us try to code. Let us try to code for this, right? Let us try to code for this. Okay. So can you give me a code, or can you try to write code? No. See, the return type is an array of integers, right? Because you are counting how many numbers are lesser than 8. That is 4. How many numbers are lesser than 1? 0. How many numbers are lesser than this 2? 1. How many numbers are lesser than this 2? 1. How many numbers are lesser than this 3? 3. So you are counting for all the elements in the array. Now that is why you have to return an array of elements. Okay, dekho. For nums of 0 equal to 8, there exist 4 smaller numbers. 1, 2, 2, 3. That is why answer of 0 is 4. Okay. For nums of 1 equal to 1, there is no smaller element. So answer of 1 will be 0. For nums of 2 equal to 2, you will have just one smaller element, that is 1. So answer of this will be 1. ऐसे कर करके. For nums of 4 equal to 3, there will be 3 smaller elements, 1, 2, and 2. So here the answer of this will be 3. Okay? ठीक है. तो चलो करते हैं. Okay? करते हैं. Okay. And guys, one thing that I told you, right, that is not always true, right? When you return from the function context, okay, that reference is lost, right? The object destruction doesn't happen immediately. Okay. What I'm telling you, I'll repeat once again. When you basically return from a function, right, the context is destroyed, right? All the variables and the things are destroyed, right? But the, the object won't be destroyed. Object thoda baad mein garbage collect hota hai. Okay. We don't have to worry about these things at this point of time, but let us just try to think of the logic for this particular question, right? So what do I do? First of all, I need to make a new array answer. Do you agree? So let's make an answer array, new int. First of all, time complexity constraints. It depends on the input output, right? So first of all, let's see what is the, can we change the name of the reference array which is already given? I will say don't do it. Why do you want to do, right? So first of all, let's find the length of the array that is given to us. Okay. Then I will, compute an answer array. I will create a new answer array of the size n. Okay. Now what I will do, guys? I run a loop for int I equal to 0, I less than n, I plus plus. So this loop I will go and iterate over every element. So when I is equal to 0, the element of my interest is ARR of I. When I becomes 1, the element of my interest is the element at index number 1. Okay. So the element that is, that is of my interest is ARR of I. Okay. And now I have to count how many elements are lesser than this ARR of I. So first of all, I make a variable int count and initialize it to 0. So this variable count will be counting how many elements are lesser than ARR of I. So now what I will do? For this element ARR of I need to iterate over the entire array. Boss, you need to check every element of the array now. Then only you will be able to determine what is the total number of elements that is lesser than ARR of I. So what do? I make another loop for iterating through the array. And from where till where? For int j equal to 0, j less than n, j plus plus. So I will again iterate over the entire array. Okay. Now, boss, what I am telling, first of all, check if I is equal to j now. Okay. If my j becomes equal to I, that means you are standing on the same element. Okay. So you don't even want to do anything. Just simply continue. Don't do anything. Simply continue and go to the next iteration. Okay. Now, tell me guys, you will come at line number 14 only if I is not equal to j. Does everyone agree? Because if I is equal to j, now you will continue and go to the next iteration. So you will come to line number 14 only when I is not equal to j. So what I will check? I compare. If ARR of j is the current element that you are standing on, if that is lesser than, okay, if that is lesser than ARR of I, if that is lesser than, sorry, nums, if nums of j is lesser than nums of I, that means this element is smaller than the element which we had considered. So what should I do, guys? I should do a count plus plus, as simple as that. Okay. So now when this inner for loop is completed, outside this for loop, can I say I know the count of how many elements are lesser than ARR of I? Yes. So what should happen? I should store this count in answer of I, because answer of I will tell me how many elements are lesser than ARR of I. So what I will do? Answer of I pe, I will write the value count. Okay. Okay, good question. If we are just comparing nums of j less than nums of I, does it matter really? It doesn't matter. That is also a good thing, right? It doesn't matter actually. Okay. हाँ, you can also do sort वॉट करके भी कर सकते हो, ठीक है. You can also sort and you can मतलब do it. Sorting करने के बाद it becomes n log and time complexity, ठीक है. But I am just giving you the most basic because the most basic or the brute force approach will also work here, ठीक है. So answer of I को count कर दिया. So when this loop, for loop, outer for loop, this finish entirely, you know that you have computed the answer for all the elements in the array, ठीक है. सही है. So outside here, what do I do, guys? I want to return an array of integers. So what do I return? I say return answer. So I return the reference so that the caller function can capture this reference and access the array object. Okay. See, guys, one very important thing, right? The array object will be destroyed when the entire program terminates. Okay. So when you return answer from here now, think of it like you are returning the reference of the array object. So somebody else will be catching that reference and referring to that array object. Okay. Is this code making sense? In line number 4, can we do new int nums? How can you do, man? How do you make an array? You have to specify the size of the array, right? How many of you are clear with this code? Let's try to run it first and see. पता चला गलत करके बैठे हम लोग and we see. Let's try to run it first. So that's giving correct. Let's try to submit it. And see, this kind of questions and logic now you should be able to code. You should be able to code. Okay. So it runs fine. And you will see that yes, it has taken some more time, more amount of time to run. Okay. But not a problem. Recursion will not be have to, recursion nahi aa raha hai. Okay. Return answer is there na? Return answer, see. See, you have to return an array of integers na. So we just return the reference of the array of integers. So the caller function will catch this reference and it can refer to the, array object that you have created. Okay. See, I am not interested in printing. Try to understand, guys. I am just writing the function. So I am returning the reference of the newly created array back to the caller. Now it is up to lead code to process this array and do whatever it wants to do. Okay. So lead code का already built-in code है जो print wint कर रहा है. I don't have to worry about that. Okay. Right? Is this making sense? And what is the time complexity? Big O of n square. As it is करना है जैसे आप. हाँ. So test में if you are wanting to return an array of integers, you have to return the reference, right? ऐसा सोचो ना भैया. What are you trying to do? What are you trying to do? What are you trying to do? You basically create an array. Okay. You fill this array, answer array, whatever, and then you return the reference. तो जो भी कॉल कर रहा होगा ना फंक्शन को, he will get access to the reference, right? He will store the reference and then he can access this array to print it or do whatever he wants. We don't have to worry about that. Okay. Why don't we take j is equal to I plus 1? Okay. So I think it is there in the logic. Think of it. If you have an array like this, 8, 1, 2, 3. Okay. Let's say you are computing how many elements are smaller than 8. Let's say you are computing how many elements are smaller than 8. So you have to iterate through the entire array now, or do you iterate just from j plus I plus 1? सोच के देखो. If I have to count how many elements are smaller than 8, you have to start from the starting now, because smaller elements can be anywhere. So definitely j will always start from 0 and go till the end of the array. Okay. Line number 14. Where is line number 14? Array, nothing, boss. You are just iterating through the array. See, this is the number 8 that I have selected, and j starts from 0. So I check. Is nums of j less than nums of I? Yes, 1 is less than 8. So I will do a count plus plus. हो गया, वैसा कर रहे हैं. Okay. And once we are outside this for loop, I know how many count is there, how many numbers are there which are lesser than nums of I. So I just write the answer in answer of I. Okay. Function में array का name return करने से क्या होता है? Think of it that what is the name of the array? It is a reference to the array. So when you return this reference now, whoever is calling this function will have access to this array object, because the array object is destroyed when the entire code terminates, when the entire, Java program terminates. Okay. And what is the time complexity? Time complexity is big O of n square. And what is the auxiliary space complexity? What is the extra space complexity that you are using? Big O of n, right? You are creating a new answer array. So it's a big O of n space complexity. Okay. 16 ms वाला code समझ में नहीं आएगा. That is using hash maps. Okay. Can't be write in one sentence. Yes, you can. Why not? Try करो अब अलग-अलग formats. Okay. Why have I initialized count inside? Because boss, for every index I, You have to compute from zero itself ना. हर element के लिए you have to see how many elements. तो count तो zero से initialize करोगे ना हर element के लिए. Okay. Let me get a poll. I think I have spent good enough time. So how do I end this poll? Guys, can you vote if you are clear with this question? And these kind of questions you should be able to do by now. अब अगर इस सब में problem है, then you need to revise and practice more of this kind. But this kind of questions should be clear now. Okay, because this is nothing. This is basic for loop usage with if else. That's it. What if we write count outside the loop? If you write count, see, at the end of the day, you have to initialize count equal to 0 inside this loop anyways. Because if you don't, then you won't get the correct answer. Okay? Okay, it's 75-14. So 89% folks are clear. The remaining 10% of the folks. Wait, 1 second. Why have I initialized inside? Chalo, ek kaam karo. What do you don't want to set count equal to 0 every time? Try to do it. Dekho, I won't answer all the questions directly, right? Ek kaam karo. You understand the logic, you understand the question, right? Try to write this count outside and do whatever you like, right? And see what happens. Okay? And then try to trace the output and see what happens. I will tell you briefly what happens if you see. If I initialize int count equal to 0 outside now, basically what I have to do is whenever this for loop starts running, try to understand, guys. देखो, मान लो मैं तुमको एक example देके बताता हूँ. Let's say, for this element, let's say for 7, you computed that the count is 3 and you wrote the answer. Okay. Now what is happening is you move to the next element 2. So now you are counting how many elements are lesser than 2 now. So this count should get initialized to 0. So if you are declaring it outside, you need to initialize it to 0 every time this loop starts running. Because for 2, if you don't change back count to 0, then what will happen? You check 8 less than 2? No. You check 7 less than 2? No. You check 3 less than 2? No. You check 6 less than 2? No. And you will say there are 3 elements lesser than 2. So for every element I, for every element num of I, first of all, you have to reset the count to 0. क्योंकि भैया हर एलिमेंट के लिए आप नए सर से तो काउंट कर रहे हो ना. How can you depend on a previous count of a previous element? You have to reset the count and count how many elements are lesser than num of I. Okay. I hope this clarifies the question. Okay. Okay. But guys, for the 11% of the folks, right, I will say you need to pay more attention and like the information tape of Mission Impossible. Why return answer? Why not answer? Because we return the reference only, right? We return the reference. Okay. Okay. If all test cases not passed, can we change the code or not at the time of module? Why not use else if? I think it's a you can use, right? It depends on your logic, right? You can use ideally, there is no problem, right? Because see, if it enters the if block, it will never come down, right? So that is the point. You can do it in that way also, whatever you are comfortable with, right? ठीक है, आगे बढ़ते हैं. So I'll move further and poll. Okay, I'm moving to the next question, right? I hope these are now we'll go to a lead code medium. Okay, and that kind of question is also very good. Okay, and you can expect those kind of questions also in the test. Okay, good question, very good question. Okay, itna difficult nahi hai, to be very honest, but it's interesting. It's interesting, right? Let's read this. Let's read this question. Okay. So for folks who are repeating, you might find this as a repetition because this question we had discussed the last time also. But I think it's a very good question to clarify some of the concepts, right? Okay. So let's have a read at the question. Maximum number of bags with full capacity of rocks. So what is the question telling? It's a lead code medium. It is telling, boss, you have n bags numbered from 0 till n minus 1. So you have n bags, okay? And the bags are labeled from 0 till n minus 1, okay? Okay? And what it is telling, you are given two zero indexed integer array. The name of one array is a capacity. You have a capacity array and you have a rocks array, okay? So the ith bag can hold a maximum of capacity of I rocks and currently contain rocks of I rocks. So what it is telling, let us try to understand, right? So you have n bags, right? You have n bags. N bags are there, okay, labeled from 0 to n minus 1. Okay, and you have two arrays, capacity and rocks. So let us have a look at the input output, right? So let's say you have a capacity array. Okay, you have a capacity array of size n itself, right? Because there are 4 bags, so there is a capacity array of size 4. Now, what does capacity of I tell me? Capacity of I tells me what is the capacity of the ith bag. See, so capacity of 0, capacity, see, this is index number 0, index 1, index 2, index 3. Okay, so there are 4 bags and the 4 bags are labeled from 0 till 1. Let us say this is bag number 0. Let us say this is bag number 1. Okay, let's just put it here. Bag number 0, bag number 1, bag number 2, bag number 3. So you have 4 bags labeled from 0 till n minus 1. That is labeled from 0 till 3. And you have a capacity array of the same size. And what does capacity of I tell me? Capacity of I tells me the capacity of the ith bag. That means if I say capacity of 1 equal to 3 hai, dekho, capacity of 1 is 3. That means the bag which is labeled as 1, this can hold 3 rocks. So the capacity of this bag is 3. Try to understand. If you see capacity of 2 is 4, that means this bag that is labeled as 2 can hold 4 locks. So what it is doing? Capacity of I, capacity array is telling you, capacity of I tells you what is the capacity of the ith bag. How many rocks can the ith bag hold? Okay. Similarly, you have another array by the name of rocks. Okay. And the size is again same as, you know, the number of this thing, the number of bags, right? Now, what is the rocks array telling me? Let's say 1, 2, 4, 4. So what are these two arrays telling me? The rocks array is telling me how many rocks are present in bag number I. So rocks of I tells me how many rocks are present in bag number I. So if you look carefully, okay, so see the bag which is labeled as 0, this has a capacity of 2, right? Let me illustrate it like this if it helps, right? It has a capacity of 2. You can store 2 rocks and currently it is containing 1 rock. See, rocks of 0 is equal to 1. So 1 rock is already present in this bag. Okay? If you look at bag number 1, capacity of 1 is 3. That is, I'm just drawing it so that you can understand it in a better fashion. You can hold 3 rocks in bag number 1. And what is rocks of 1? Rocks of 1 is giving you 2. That is, 2 rocks are already present in this bag. Okay? Something like this. Then you have another bag labeled as 2. Okay? The capacity of this bag is 4. So this bag can hold 4 rocks. Okay? 1, 2, 3, 4 rocks this bag can hold. And how many rocks are present? Rocks of I is 4. So this bag is filled with rocks. Okay? It is consisting of 4 rocks. Okay? So this bag is completely full. All 4 rocks are present. Okay? Then capacity of 3 is telling me 5. That is, the bag which is labeled as 3, it has a capacity of 5, right? The boss, you can actually fill, 5 rocks. 1, 2, 3, 4, 5 rocks can be put inside this bag. Okay. And what is rocks of I? Rocks of I is giving me 4. That is, 4 rocks are already present in this particular bag. Okay. This situation मेरे को बता दिया कि boss, there are n bags labeled from 0 to n minus 1. And you have a capacity array where capacity of I tells me what is the capacity of the ith bag. How many rocks can the ith bag hold? And the rocks array is another array which tell me, rocks of I will tell me how many rocks is the ith bag holding. So this is the situation that I understand. Okay. Now what it is telling me? Boss, you are also given an integer by the name of additional rocks. So you have some more number of rocks, right? You have some extra number of rocks. Okay. Let's say here additional rocks is 2. That means you have 2 more rocks. You have 2 more rocks with you. Okay. And you need to put these rocks, you need to put these 2 extra rocks inside the bags. Okay. And what it is telling me, return the maximum number of bags that can have full capacity after you place the additional rocks. So मैं क्या बोल रहा हूँ, boss? You have these 2 additional rocks and you want to place these 2 additional rocks in the bags. Okay. And you need to tell me how many maximum number of bags can get to full capacity. So what I will tell you, in this case, if you see very carefully, right, I can take 1 rock and put it inside this bag. This becomes full. Okay. I take another rock and I can put it inside this bag. This bag also becomes full. So after placing these 2 rocks, how many bags have become full? 1, 2, and 3. 3 bags have become full. So my answer is 3 bags can become full. Okay. And you will see that, anywhere you put 2 rocks, more than 3 bags can never become full up to the brim. So my output should be 3. So you have to tell, bhaiya, you have some rocks and you can place it in different bags, right? Depending on how much space is left in the bag. And you need to tell what is the maximum number of bags that can become fill after you put the additional number of rocks in the bags. How many of you understand the question? I'll give another example also. Where is my this thing? Where is that thing? Just 1 second. Yeah. Yes. How many of you understand the question? Let's take another example, right? Let's take another example, right? So let's take another example. Repeat, okay? I'll repeat. See, you need to understand the question from the wordings, right? You have n bags labeled from 0 till n minus 1. So आपके पास n different bags है. You have n different bags and let me call the bags as 0, 1, 2, 3 till n minus 1. So there are n different bags and there are labels on every bag, right? From 0 till n minus 1. There are n different bags. Okay. Now मेरे को क्या बोल रहा है, boss? You are given two arrays, capacity and rocks. Okay. And what is the capacity array telling me? The capacity array is telling me, see what it is telling me, right? Capacity of I, if you inspect the element at the ith index of the capacity array, it will tell you what is the capacity available or what is the capacity of bag number I. So if I inspect capacity of 4, if I inspect the element present at index number 4 of capacity array, it will tell me what is the capacity of bag number 4. कि boss bag number 4 कितना rocks contain कर सकता है. So what will be the size of the capacity array? The size of the capacity array will also be n. Okay. So it will also contain indexes from 0 till n minus 1. So capacity of I will tell me what is the capacity of the ith bag. So if I want to find what is the capacity of this last bag, which is labeled with n minus 1, I just need to see what is the element at capacity of n minus 1. So the capacity array basically tells me what is the capacity or what is the number of rocks that you can store in the ith bag. Okay, ये हो गया capacity. Then it is telling, boss, you also have a rocks array. Okay, देखो, the ith bag can hold a maximum of capacity of I. So capacity of I tells me what is the maximum number of rocks that the ith bag can hold. Okay, बहुत ज्यादा डालोगे तो ब्रेक हो जाएगा, है ना, फट जाएगा बैग. तो बता दिया कि भैया ये जो प्लास्टिक का बैग है, this can only hold let's say 50 rocks. So capacity of I is 50. You cannot hold more than 50 rocks in the bag. ठीक है? And the ith bag currently contain rocks of I number of rocks. So there is another array rocks. Okay, and if you inspect rocks of I, let's say if you check rocks of 4 now, it will tell you how many rocks is currently present in bag number 4. So rocks of I will tell me how many rocks are currently present in the ith bag. This information is given to me. ठीक है? अब फिर मेरे को क्या बोलता है कि boss, you are a person, right? And you have some extra number of rocks. तुम्हारे हाथ में ना कुछ और rocks है, some additional number of rocks. Let's say you have 5 rocks in your hand. ठीक है? You have an integer additional rocks which tells me how many rocks you have extra. और मेरे को क्या करना है? I want to put these rocks in the bags. Okay. And what I want to do is I want to maximize the number of bags that are becoming full. ठीक है? I want to maximize the number of bags that become full. तो मैं कैसे इनको डालूं कि मेरा bags maximize हो जाए? So I want to tell you, after putting these 5 rocks inside the bags, how many maximum number of bags can become full? Let me take an example and it will become more clear. Okay. Let me go to the PPT. Let's say you have certain bags, right? Let's say you have certain bags. This is your bag number 0. Okay. This is your bag number 1. Okay. And let's say this is your bag number 2. Okay. So let's say I am just taking a very, simple example to make you guys understand. Let's say you have a capacity array of size 3. Okay. Simple example here. Capacity array is also of size 3. Let's say the capacity of bag number 0. Let's say the capacity of bag number 0 is 6. Okay. Let's say the capacity of bag number 1 is 8. Okay. And let's say the capacity of bag number 2 is 4. Okay. Assume kar lete hain. Okay. And now what I am telling you, let's say the number of rocks, right? I am telling you, boss, bag number 0 contains 2 rocks. Bag number 1 contains, let's say, 5 rocks. Okay. And bag number 4, let's say it contains 2 rocks. Okay. Or let's call it like this. एक minute. Let me take an example which helps you to understand. Okay. Okay, let's do it like this. Okay. So capacity 7 and view. Okay. And I tell you, boss, so if you want to understand, right, this bag can hold a maximum of 7 rocks. And currently it contains 2 rocks. Okay. Currently it contains 2 rocks. So how much more rocks can this bag hold? 5 rocks. 5 rock और तुम इस bag में डाल सकते हो. Okay. For bag number 1, okay, the capacity is 8 and currently it is containing 5 rocks. So how many rocks can you put in more? 3 rocks. 3 rocks का जगह है इस bag में. And if you look at bag with index 2, the capacity is 4 and currently it contains 2 rocks. So how many rocks can you place in more? You can place in 2 more rocks. And मैं तुमको बोलता हूँ, boss, the number of additional rocks that you have, is let's say 5. ठीक है? मेरे पास 5 rock है, right? And I want to put these 5 rocks in the bags. And I want to maximize the number of bags that are getting full. So guys, try to understand. You can put these 5 rocks in different ways. मेरे को मन किया तो what I can do? I can take these 5 rocks and I can put these 5 rocks inside bag number 0. Okay, 5 का space है ना इसमें खाली. So I put all these 5 rocks in bag number 0. And if I do that thing, how many bags will become full? 1 bag will become full to the capacity. Bag number 0 will become full to the capacity. But so in this case, bag number 1 will just become, bag number 0 will become full. And you will say, boss, 1 bag has become full. But is it the maximum number of bags that are getting full? No. Because what I can do is, I can take these 5 rocks, I can put 2 rocks here, and I can put the remaining 3 rocks here. If I put the rocks like this, then 2 bags will be full up to the potential. 2 bags will be filled up to the capacity. Okay. And this is the best way in which you can fill up the bags. So my answer will be 2. Boss, if I put the 5 bags, the 5 rocks in the bags, the maximum number of bags that can become full is 2. You cannot fill more than 2 number of bags up to the brim. देख लो और कैसे भी place कर लो. Let's say I put 3 rocks here and I want to put the remaining 2 rocks here. Still you will find that only 1 bag is filled up to the capacity. Okay. So the most optimal distribution is like this only. 3 rocks here and 2 rocks here. And you will say, boss, 2 bags have become full up to the capacity. So my output will be 2. The maximum number of rocks that can become full is 2. The maximum number of bags that can become full is 2. Making sense? Yes? ऐसा सोचो guys कि you have guests in your house. Okay? You have guests in your house. ठीक है? So guests have come. You didn't know, right? They gave you a surprise and the guests came. ठीक है? अब you basically have a jug. ठीक है? You basically have a jug. Okay? You have this is a jug. And you have prepared some drink, right? You have prepared some drink for the folks, right? ये मेरे पास है, ठीक है? And there are certain number of glasses. Okay, you have certain number of glasses, ठीक है? अब मान लो, this glass is already full. Okay, this glass is already full. Okay, only let's say 5 ml of space is left. Okay, and let's say this glass only has 10 ml of space left. Okay, and this glass is entirely empty. Okay, this glass has a capacity of 50 ml. And this glass is entirely empty. Okay. And if I tell you, boss, you just have 20 ml. आपके पास खाली जग में 20 ml liquid है. And your mom comes and tells you, hey Adarsh, please make sure that you are serving maximum number of guests. भैया जितने guests को खुश कर दो उतना अच्छा, right? Try to serve maximum number of guests with the entire glass, right? So what I will do, if I put this 20 ml here, I will be a fool, right? Because then no guest will get the full capacity of the glass, right? So if I am wise, what I will do? First of all, I will always give the preference to this glass. See, मेरे पास कितना भी liquid हो ना, I will first of all give preference to this glass. Why? Because this glass has the least amount of space and this will get full in a very small amount. Okay. So I will first put 5 ml here, fill the glass. Then I will put 10 ml here, fill the glass. And then remaining, I will put in glass number. Let's say glass A, glass B, glass C, glass number C. So what is the idea? The idea is this, right? I want to maximize the number of, bags that are getting filled. So what I will do, I will try to first of all fill the bags which have the least amount of space left. क्योंकि भैया जिस बैग में सबसे कम स्पेस होगा ना, that will become full easily. You have the best chance of making that full. Okay. Are you getting what I'm trying to say? How many of you are understanding what we are trying to do here? See, these kind of questions will come, right? Because this is sorting also, plus after sorting, you have logic also. This is the level of questions that you can expect, right? So first of all, what should you do, guys? First of all, your job should be to find what is the remaining space in every bag. Okay, let's try to code it up, right? Let's try. How can we add 2 additional rocks in 3 bags? Yes, already filled bags will be counted, right? Now let's go to the code. What if rocks still remained after filling the bags? कोई दिक्कत नहीं है. अगर बच गया तो ठीक है ना. Let's say your question is, let's say you have 2 bags, right? Labeled 0 and 1. And the total space that is available is 5. And you have 8 rocks. No problem. No problem. Just say that whatever rocks you can put in, after that, both the bags will become full. Okay? Now let us go to the coding logic. Okay, now let us go to the coding logic, right? You need to practice reading questions, right? आपको questions read करके थोड़ा आप समझना पड़ेगा, right? See, this is the best level that I can, मतलब मेरे को ये काफी अच्छा question लगता है because it also allows you to sort. It also lets you think कि after sorting what you need to do. Plain simple sorting does not do our job, right? So first of all, let us see how many bags are there. Let us try to code it up, right? Int 10 is equal to capacity dot length. Okay. See, you have two arrays, capacity and rocks, and you have this integer additional rocks, which will tell me how many more rocks that you have. So int n is equal to capacity dot length. Okay. And the size of the rocks array will also be the same. Now, first of all, guys, I want to calculate what is the remaining space in every bag. Okay. I first of all want to calculate what is the remaining space in every bag. So can I do something like this? If I do this operation, the boss capacity of I is equal to capacity of I minus rocks of I. If I do something like this, what will happen? Let's say I tell you, boss, the capacity of a bag is 8 and it has 5 rocks, right? So when I do 8 minus 5, you will get 3. Okay. And when you assign this to capacity of I, do you agree when you do this operation, capacity of I will next tell you how much space is remaining in every bag? Does everyone agree? Therefore, the original value of capacity of I is what is the maximum rocks that bag can store. And rocks of I is usme kitna already hai. So if you minus these two, it will tell you what is the space that is pending in the bag or remaining in the bag. And I assign this difference back to capacity of I. So after this operation, capacity of I will tell me how much space is left in the ith bag. Okay? So there is not a problem with creating a new array. You can do that also. But if you can reuse, that is also good, right? कर सकते हो create, कोई दिक्कत नहीं है, ठीक है? So what I will do, I iterate over the array. For int I equal to 0, I less than n, I plus plus. I iterate over the array. And what do I say? Capacity of I write something like this. Capacity of I minus equal to rocks of I. So after this operation, capacity of I. Now, after this operation has been done, capacity of I tells me how much space is left in the ith bag. That is what now capacity of I is telling me. Okay? Now capacity of I tells me how much space is left in the ith bag. Now what do I want to do, guys? I want to give the preference to the bag which has the smallest space left. Then you will take. Now see, guys, let's say मैं तुमको बोलता हूँ. Sorry. Yeah. Let's say if I tell you, you have a bag which has two units of space left, right? I tell you 2 units of space is left. There is a bag which has 10 units of space left. There is a bag which has 5 units of space left. There is a bag which has 3 units of space left. So first of all, I should fill rocks in this bag. Then I should fill rock in this bag. Then I should fill rock in this bag. Then I should fill rock in this bag. So what are we doing? First of all, I want to access the bag which has the smallest space left. Then the second smallest space left. Then the third smallest space left. Then the fourth smallest space left. Because I want to maximize on the number of bags that are getting filled. So do I not want to sort my bags according to capacity? So मैं बोलता हूँ, guys, try to understand what is the capacity array telling me. The capacity array is telling me that bag 0, let's say bag 0 has 5 space left. Bag 1 has 2 space left. Bag 2 has, let's say, 10 space left. Bag 3 has 4 space left. ऐसा कुछ बता रहा है. So now I want to access the bag in increasing order of the space left. So I will just sort this capacity array. Okay. See, you will lose information ki which bag had which space, right? When you sort, 2 will come at index number 0. Okay. And the information will be wrong that bag with index 0 has capacity 2. But I don't care about indexes, right? I just want to see how many bags will become filled. So what do? I sort my array. I sort my capacity array because I want to access bags in according of their space left. Okay. So let's do arrays dot sort capacity. I sort the capacity array. Done. Now what do? After I've sorted the capacity array, what do? Now I will iterate over the capacity array. अब ऐसा सोचो guys, let me clean up the screen. Let's say you have 2 here, 2, 3, and let's say you have 5 here, right? And the number of additional rocks, okay, let's say the number of additional rocks is let's say 4. No, let's say 5. Okay? Or let's say 6, right? The answer won't change here. Okay. Okay. So let's say the number of additional rocks is 6. I want to place 6 additional rocks. So what will I do? First of all, I come to this element and I see that the space that is left in bag is 2. And how many rocks I have? I have 6 rocks. So what should I do, guys? If I tell you, if the number of additional rocks that you have, try to understand. If the number of additional rocks that you have is greater than or equal to capacity of I, iska matlab kya hua? What is the physical meaning of this? 6 is greater than equal to 2 na. That means this bag can become full to the capacity. This bag can become full to the capacity. So what I will do? I will do a count plus plus. मैं बोलूंगा boss, one bag has definitely become full. This bag will become full. And what should I do? How many rocks will go inside this? 2 rocks. So what should be the number of additional rocks that you have now? You have 4 number of rocks. And then you move forward. You move forward, right? So if additional rocks was greater than equal to capacity of I, what did I do? I did a count plus plus just to make sure that boss, this bag will become full. And then what do? What do? I will also reduce the number of additional rocks that I am carrying. By what? Additional rocks minus equal to capacity of I. Dekho na, capacity of I was 2 and the rocks that you had were 6. So 6 is greater than equal to 2. So you can put, this bag will definitely become full. So I made my count 1. And once you have put, how many rocks will you put here? 2 number of rocks only. So how many rocks are you carrying? 6 minus 2, that is 4. Okay? I move forward. Now you have 4 rocks. You have 4 rocks. And what is the capacity of this bag? 3. है ना? 3. Are we doing correctly? 3 होगा ना यहाँ पे. There, how many additional rocks did we take in the first place? Wait. कितना rock लिए थे हम लोग? 6 लिए थे या 5 लिए थे? I think we took 5, right? So let's say you had 5 additional rocks in the beginning, right? So now you have just 3 additional rocks, right? Now what do I see? 3 is greater than equal to 3. 3 is greater than equal to 3. So how many rocks can you put here? See, 3 number of rocks you have and this bag can accommodate 3 rocks, right? So this bag will become full. So I will increase my count equal to 2. Okay. And I will say now you are carrying forward 0 rocks. Okay. Now you move forward. The moment you see that the number of rocks that you have is less than capacity of I, right? The moment you see that the number of rocks you have is less than the capacity that is available in this bag, what do? You know कि और कोई भी bag अब नहीं भरेगा. Let's say you had 2 rocks here. Okay. Will any of these bags become full? No. So simply break out. Okay. Let's take another example. Let's say that one of the bags is already full. Okay. One of the bag has a capacity 1 left. One of the bag has a capacity 5 and one of the bag has a capacity 10 left. Okay. And let's say the number of additional rocks. Okay. The number of additional rocks is 7. So what do? You iterate, right? What is the capacity of this bag available? Kitna bacha hai jagah? 0. Okay. So is 7 greater than equal to 0? Yes. That means this bag will become full. So I make increase in my count. Count becomes 1. And how many rocks will I put in this bag? 0 rocks. So what is the rocks that I carry forward? 7 minus 0, which is 7. So I move forward. And now still I have 7 rocks. Okay. Now 7 is greater than equal to the capacity of this bag. That means this bag will also become full. It has 1 space and I have 7, right? Greater than equal to. So this bag will also become full. So what do? I increase my count. Ki boss, 2 bags will become full. And I decrease the number of rocks that I am carrying. 7 rocks tha and 1 rock will go here. So now you are just carrying 6 rocks. Move forward. Now you have 6 rocks. Okay. I see that 6 is greater than equal to 5. Okay. So this bag will also become full. Increase your count. And now the number of rocks that you are carrying will become 1. Move forward. Okay. Now you see, boss, the number of rocks that you have is 1. And the capacity of this bag remaining is 10. So 1 is less than 10. So definitely you won't be able to fill this bag. और अगर यही bag नहीं fill हो रहा है, so even if you had other bags after it, no one will become full, right? So what do I do? The moment you see that additional rocks is less than the capacity that is available, you simply break and I say that, boss, 3 bags will become full up to the capacity. Is this logic making sense? Is this logic making sense? I'm trying to go very slowly. Is this logic making sense? Yes? Okay. Great. Let's code it up. Check how many elements. Yes. Okay. So let's quickly code it up, right? So now what do? I will be iterating over the capacity array, right? For int, let's say I equal to 0, I less than n, I plus plus. I'm iterating over the capacity array. And what do I first of all check? Acha, make a count variable, which will tell me how many bags can become full at max, right? Let's make a count equal to 0. Now what do I check? If the number of additional rocks that you are carrying is greater than equal to capacity of I, if the number of additional rocks that you are carrying is greater than equal to the space that is remaining in this bag, okay? If the number of rocks that you are carrying is greater than equal to the capacity of I, so what I will do, boss, this bag will become full. So let's increase a count. And how does this bag become full? You will put some rocks. Kitna rocks? Capacity of I, number of rocks. So how many rocks you will be left with? Kar lete hain. Additional rocks will be now additional rocks minus equal to capacity of I. Okay? Because capacity of I rocks will go inside the bag to make it full. So now you have less number of rocks available to you. That you do and you move forward, right? Else, the moment you see that, boss, additional rocks, when you will come in the else block, when additional rocks is less than capacity of I, that means that bag cannot become full. And if that bag cannot become full, no other bags also can become full. क्योंकि भैया उससे ज्यादा ही स्पेस मिलेगा आगे वाले बैग्स में. So what I will do? Simply break. No need to run the loop any further. Simply break. Now when I come outside the for loop, count has my answer, and I need to just return the answer, right? Which is the count. So I will simply return count. Okay. Let us try to run it first. Okay. Let's submit it. Okay. See it ran. So what is the time complexity of this code? If you see, the time complexity is n log n because you are doing a sorting, right? So this is taking big O of n, this is taking big O of n, right? It is 2n plus n, 2n plus n log n to be very precise. But n log n is more dominating as compared to n. So if someone asks me the time complexity, it is big O of n log n because I am doing a sorting. And what is the space complexity? Have we taken any extra space? No, I have not taken any extra space. So the space complexity is big O of 1. Okay. Opening the poll once again, just to check out how many of you are clear. Yes, guys, please cast your votes so that I get an idea of how many folks are clear. Okay. This is good, yeah. It also tells you the percentage of participation. It's 75% participation that we are seeing. Okay, great. Better than previous. तो मेरे को समझ में आ गया problem क्या था. You guys are lazy and you don't want to go to the other website, right? And it's good that I found Zoom polls. सही था, मैंने पहली बार ही try किया, but it's good, right? Okay, so I see almost 88% folks are clear, right? So great. So these kind of questions you can expect, right? You have to do. देखो ये question में क्या था? You had to do a sorting. And after sorting, you had some logic, right? So these kind of questions you can definitely expect in the exam as well. Okay. Cool, guys. Okay. So I hope these problem solving is also helping you guys to develop some more intuition and more idea of how to approach questions, right? Yeah, this is an interesting question. मतलब उतना tough भी नहीं है, उतना easy भी नहीं है, right? How n log n? What is the time complexity of arrays.sort? Arrays.sort का time complexity n log n है. Okay. Why else break? Why did I do a break? Why did I do a break? Because let me just do a quick dry run of this question, right? एक बार कर देता हूँ dry run फट से. See guys, try to understand, right? I'll just take the previous question, right? See the first, let's say 0, 2, 3, 10, okay? And let's say you have additional rocks as 6, okay? You have 6 rocks. Okay? And these are the spaces in the bags. So what I do, I start from the beginning. So this bag has capacity of I as 0. So this bag is already full. So I check. The number of rocks that I have is 6. 6 is greater than equal to 0. So definitely this bag will become full. So I increase my count. Ki boss, one bag has become full. And how many rocks will go inside here? The space that is left in the bag, that is 0. So how you will put 0 rocks? So what is the new number of rocks that you have? 6 minus 0, which is 6 itself. Move forward. What is the space left in this bag? 2. How many rocks you have? 6. So definitely this bag will become full. 6 is greater than equal to 2. So this bag will become full. So you enter the if block, you increase the count, and boss, how does this bag become full? By putting 2 rocks here. So how many rocks will you have? 6 minus 2, that is 4. So I update my additional rocks. Move further. I come to this bag. How much space is left? 3. How many rocks I have? 4. So 4 is greater than equal to 3. So this bag will also become full. So I increase my count and I update ki 3 rock gaya. So additional rocks will now become 1. Move forward. This bag has a capacity of 10. Is 1 greater than equal to 10? No. 10 space बचा है ना इसमें, and I have only 1 rock. So can I fill this bag? No, I cannot. अब सोचो भैया, जब यही बैग नहीं भर पाए, तो can you fill any of the bags that are after this? अगर तुम 10 साइज के स्पेस कोई नहीं फिल कर पा रहे हो, then how can you fill 15 or 20? You cannot, right? So the moment I see that I cannot fill a bag, I simply break हो जाओ. Okay, come outside and I say, boss, 3 bags can become full. Okay, cool guys. I hope this makes it more clear to understand. Yes. Okay. Okay. How can we classify this question? Lead code does that. Yeah, I think this is hard according to exam. You can think of it, right? You can think of it, right? Okay. So now guys, hopefully I'll assume that time complexity n log n. What is the time complexity? Just see, this is big O of n, this is n log n, this is again big O of n. So it is 2n plus n log n, right? If we not do break, why? But break kar jao, kya dikkat hai? Okay. If you don't do break, what will happen? You will just keep on moving forward. Kuch hoga nahi. Even if you don't do, that is fine, right? But why do you want to move further? Okay. So let's move further. Okay, guys. So we have 15 minutes. So what I will do, so I will hope that you are clear with the couple of questions that we discussed today. Okay. And how to approach function-based questions, you are clear, right? And the second thing that I wanted to ask you, hopefully you are clear with merge sort. Okay. And please try to do a, dry run of the merge function and merge sort, right? And all bag fill full and also some rocks available. How to code? Same code will work. What happens, guys? Think now. Even if all the bags have become full, right? So you will increase the count and you will return the count, right? क्या होगा? इसी को करके देखो. Okay. Know the stability. So arrays.sort actually uses a dual pivot quicksort kind of thing, right? So even I am not sure on the stability. You can Google that up. मैंने भी इतना कभी सोचा नहीं. ठीक है. But hopefully that is more clear, right? What is lead code format? This function completion, right? We didn't have to take the input. We didn't have to print anything. Okay. Okay. So what I'm expecting now is in the last 10 minutes, let me just give you an overview of QuickSort, right? What is the idea behind QuickSort? So that when we meet tomorrow we will do QuickSort discussion. And then on Friday, we will do some more problem solving. Okay. And after Friday, I think it should be good that if we give you self problem solving and self practice time so that you develop more understanding and insights. Okay. Good. Almost 90% folks have answered. So let's end this poll here. And let's just come to the, QuickSort discussion for 10 minutes, right? So that, you just know what is QuickSort all about. Okay. I would understand. I would say that this type of question is hard according to, your module test. Lead code के लिए medium है, but अभी तुम लोग के लिए this is a difficult question. So folks who are understanding these, good. That's good, right? अच्छा, ठीक है. But again, you have to get the logic in the test yourself, right? In the test, I won't be there to help you guys with the logic. So that is where you have to focus and improve, right? Okay. So what is QuickSort all about, right? Let me just give you a very basic introduction about QuickSort, so that when we meet tomorrow, we can try to take up QuickSort and move forward. Okay. ऐसा मत सोचना कि टेस्ट में नहीं आ रहा है तो you don't pay attention, right? Just pay attention because it will help you in the long run in interviews and all those things, right? So what is the basic idea behind QuickSort? Okay. So I think everybody has attended a school assembly, right? Everyone stood in the assembly lines in the school, right? And what happened in the school assembly line? Your teacher will ask you to stand in, increasing order of your heights, so that everybody can view the stage. Let's say if your stage is here, okay, try to imagine, right? My drawing is bad, but in the school assembly line, if everybody has to get a clear view of the stage, everybody will, the teacher will ask you to stand in ascending order of your height, so that every person can view the stage. Agar aisa hua ki let's say you are standing here and behind you is standing a smaller person, then his vision will be get blocked, right? And let's say if in front of you a longer person is standing, same story, your vision will be blocked. So if you want to, get a clear view of the assembly, you have to stand in ascending order lines. Okay. So what your teacher does is, teacher comes and asks me, hey Adarsh, can you please go and stand at your correct position? Teacher मेरे को आके बोलती है, hey Adarsh, can you please go and stand at your correct position in the line, so that I don't have to move you from your position. ध्यान से सुनो. Teacher comes and asks me, hey Adarsh, can you please go and stand at your correct position in the line, so that I don't have to move you. So how will I stand? I will stand in such a location. I will go and stand in such a place, such that all the people who are of a smaller height than me, they are in front of me. And all the people who are of a greater height than me, they are behind me. If I stand in such a location, can I tell the teacher, hey teacher, you know what? I don't know whether these folks are standing correctly or these folks are standing correctly. ऐसा हो सकता है कि there is a longer person here and there is a longer person here, right? Okay, I don't know whether their internal ordering is correct or not, but I can tell the teacher, hey teacher, you know what? I am standing at my current position. You won't have to move me from this position. This is my fixed position. You might have to go and do some internal rearrangements among these two blocks. Okay. ऐसा हो सकता है. See, try to understand. If my height is, let's say, 6 feet. Okay. Here you can get an 8 feet and here you can get a 7 feet, right? That is something that is possible, right? But in that case, the teacher will ask them to change their position. I won't get affected. Okay. There can be happen that a person of 2 feet, okay, or let's say a person of 3 feet is standing before a person of 4 feet. Or let's say, a 4 feet person is standing ahead of a 3 feet person. समझ रहे हो मैं क्या बोल रहा हूँ? Internal arrangement might not be good, but I can claim that, hey teacher, I am standing at my correct position. You might have to do some internal rearrangements, but you can't displace me from my position because this is my correct position. Okay. But if some situation like this happened, I am standing here, right? And if somebody of a higher height is standing in front of me, then the teacher will have to change my position. Teacher क्या बोलेगी? Hey, this person, please go and stand behind. So you will come and move forward. So your position will get disturbed. If somebody of 7 feet is standing before you, so you will have to go forward and he will have to come back. So you will have to get disturbed from your position. Similarly, if somebody of a lesser height is standing behind you, still you will have to move back and he will have to come forward. So you will have to move your position. So if you want to make sure that you are standing at your correct position, you have to go and stand in such a manner that all the people who are of a lesser height, they are in front of you, and all the people who are of a greater height are back, they are after you. So you can very confidently tell the teacher, hey teacher, I am standing at my correct position. Teacher might want to shuffle them or do a rearrangement among these two blocks, but I am pretty sure that she won't have to move me from my correct location. Is this point making sense? Logically socho guys, if I stand in such a way, can the teacher be forced to move me? Never. I am standing at my correct position. Yes. So this is the same concept that QuickSort uses. So let's say, I'll just give you an overview. So let's say you have to sort an array. Okay. Let's say you have to sort an array of integers. Let's say 8, 7, 12, 6, 5, let's say 10, anything like this. This is an array, right? I want to sort this array. So what do I tell? Hey boss, sorting this array is a very, very complex task. Very, very complex task. But what I will do, I am a teacher, right? I pick this element. Let's say I pick this element and I say, hey, 8, can you please go and stand at your correct position? I will take this element and I make sure that this element is at its correct position. I somehow make some rules or some logic to ensure that this 8 is standing at its correct position. So how will my array look like? 8. Okay. Now, there can be something like this 6, 5, 7 here. I don't care. And here there can be something like, 10, 12. Okay. So can I say, boss, the element 8 is at its correct position. All elements lesser than 8 are to the left and all elements greater than 8 are to the right. So what I will tell you, my array is looking like this, suppose, right? I tell you, boss, now 8 is at its correct position. I don't have to disturb 8. So what I will tell? Now, can you please sort this left part of the array for me? And can you please sort the right part of the array for me? So see, I'm calling two smaller subproblems. And once the left and the right part are sorted, how will your array look like? 5, 6, 7. This is the sorting of the left part. 8 is here as it is. And the sorting of the right part is 10, 12. So hasn't my full array become sorted? So what do? I pick an element. I make sure that that element goes to its correct position. And all the elements that are lesser are in the front of it. And all elements that are greater are behind it. So once I have made sure that this element is at its correct position, मेरे को पता है भैया, nobody can disturb this. So I will ask my hey, can you please now sort this smaller part? मैं teacher क्या बोल रही है? Now I will have to do an internal rearrangement of the people who are in front and the people who are in back. But I know that this 8 is at its correct location. So I will sort this array, call the same function for a smaller problem. We sort this array. And once this part of the array is sorted, you get a 5, 6, 7. Then I say, can you sort the right part also? When this is sorted, you get 10, 12. And once the left and right part are sorted, kya hua, boss? You were at your correct position. The people standing in front of you are also now in correct locations. And the people who are behind you, they are also standing in correct locations. So now has the entire line become sorted? Soch ke dekho, guys. Think of it. You are standing at the correct position. Now the teacher just calls the same function. He please sort this part of the array and sort this part of the array. Once the left and the right parts are sorted, the entire array will become sorted. Is the basic idea. Kaise sort ho raha hai? What will the teacher do? The teacher will again tell somebody, hey 6, can you go and stand at your correct location? So 6 will go and stand at the correct location. And then again, this function will work recursively. But abhi ke liye usko chodo. We will see it tomorrow, right? But is it making sense what we are trying to do? If I take one element, see how am I dividing this array? I take an element, make sure that goes to its correct location. 2 parts. I say sort this array, sort this part of the array. Dono sort ho gaya, you will see that your entire array has become sorted. So it is a divide and conquer problem. You are sorting the smaller subparts and then the entire array becomes sorted. Okay. Okay. Is the basic idea making sense, guys? क्या करना चाह रहे हैं हम लोग? Yes. Okay. What's the time? Okay. Just 2 quick pieces of information, right? So the element that you select, okay? मान लो you had an array like this, right? 8, 7, 6, 5, 10, 12, right? So I first of all choose an element, right? So the teacher was choosing me first. Hey, others, go and stand at your correct position. So the element that you choose, that is known as the pivot element. हम लोग बोलते हैं this is the pivot element. The element that you choose now, that is known as the pivot element. And once the pivot element goes to its correct position, okay, once the pivot element goes to its correct position, I say that, boss, the array has been partitioned into 2 parts. So I say that now the array has become partitioned. Okay, this is the correct location for my pivot. And there are 2 partitions created, the left partition and the right partition. Okay, so what is the correct index of this 8? I call this index as the partition index or the pivot index. So I choose the element as a pivot. I make sure that yes, that pivot element goes to its correct position. And once the pivot element is at its correct position, I say that the array has become partitioned. I have done the partitioning process. Okay, I have partitioned it into 2 parts. Okay, and this index, let's say this is index number 4, 0, 1, 2, 3. So this index number 3 is the correct index for this pivot. So I say that this is the partition index or the pivot index. Okay. How we are choosing, we will see tomorrow. Okay? But you just need to understand what is a pivot element, the element that you choose to send to its correct position. And once that element goes to its correct position, you say that you have performed a partitioning function. And this index at which this element is there, that is known as the partition index. Okay? Give the topic wise names of the gym section problems to solve DP. Okay. Okay. Okay, I'll do that. I'll do that, right? I'll share a list of some questions. Let me ask some folk to collate that, right? So that you can also practice it during your self-solving time, right? See, the reason, okay, I'll stop recording at this point of time because I think we are done with the class. We'll look at it tomorrow.